Everybody got a lab guy? Everybody got a lab guy? You don't need to clap back. Put that in your bag. Put it in your bag. Listen, people. If you were sending a text message on your phone during off and out of sight, I only have one recourse.
Send her to the ARC.
I know. I feel like you guys don't believe me.
This should be like a...
Do it. Send Jaden right now.
You won't.
Yeah, you won't.
Oh, don't tempt me. You know I will. All right. You guys see my cute little car here? Now, it has an on switch. Can you see the car catcher? So I turned it on, and now it's going to roll. I know. It's so exciting. All right, pick it up and send it back. Very nice. Oh, that was excellent. Oh my God! Oh! Tell me what you notice about the car.
It moves.
Definitely moves. Good. Yes.
Headlights.
Yeah, it totally has headlights.
It has wheels.
Definitely.
Powered by the chassis.
Okay. Nice plastic chassis. Good. Go ahead.
Same speed. Do the back two wheels spin or all four of them?
I think it's four-wheel, or I think it's all-wheel drive.
Oh, yeah.
They move at the same speed. Four-wheel drive.
Is it four-wheel or all-wheel?
It's like...
Four-wheel.
I don't think those are the same thing.
Well, I mean,
The car's on four wheels out here.
It's only half hour.
They both have check.
They're both the same.
What's that?
I think nothing.
Nothing? What'd you say about speed?
They like remain the same.
Does it seem like the car is going at a constant speed?
Yeah.
Are you sure?
It seemed like it was faster in the beginning. Then it's
Let's watch. Okay? It's like when I just sat down.
Well, we also did take it off.
Well, after. Oh my God.
It's missing gears too.
Okay.
It's not safe.
They didn't have a turn signal.
Where's the license plate?
There is a license plate actually. It's for the company that I bought it from. Put their own little sticker on the back. Does it look like it might be going at a constant speed?
Yes.
Maybe. Okay? So what I want to do is, before we get too far into the lab guide, I want you to answer this. You're good. I want you to answer this question. How could we measure the speed directly? Okay? Just check with your neighbor on this one. How could you measure the speed directly? Check your neighbor now. See if your neighbor has an idea. How could we measure the speed directly?
Is this a question?
It is no. This is just a general question.
Radar gun.
Oh, for 18 days. Is there a test when she gets 720 No, we're talking about it. Wait, are you talking about the 8 weeks? Yes, isn't it 741? Oh, okay, so.
All right, you guys ready? Who has a suggestion? How could you measure the speed directly?
Radar gun.
Radar gun is an excellent answer for that. A radar gun, because if you shoot it with a radar gun, it'll say your speed is. I, however, did not bring my radar gun today. BYO radar gun. Did anyone bring your own radar gun?
I left it in my locker.
Okay, so that's a problem. Okay, give me another way you can measure the speed directly. Yes?
Have like a starting line, like an ending line, so like 3 feet and time it.
So, did you hear what you guys hear what Abby said? She said, draw a starting line, let the buggy roll to some distance over here. So this is the start, this is the finish, right? And this is some distance d, and then you're going to get some time t. Now, you can do this, except for, are either of these a measurement of speed?
No.
No, this is a measurement of distance. this is a measurement of time, and you can measure distance in time, but does that give me the speed directly? It doesn't. You see my problem? But we're gonna go with that in a second. But let's see if we can get some directly measurements. ISIS.
Would velocity be more direct?
Velocity and speed are, at this point, they're the same concept. So
Okay.
velocity tells you how fast.
Okay.
So does speed. Okay? So we're gonna get there. Yes?
See how many hours it takes to do a mile?
Totally, right? Because it's miles per hour. That's the same thing here, right? See how many hours it takes to do a mile? One is a time measurement, the other is a distance measurement. Okay? But we're gonna do some time distance measurement. I want to see if we can measure the speed directly. Roy?
Well, you have the camera set up, and also there's a blinking light on the car, so I'm guessing those are kind of in relation. So you measure how many times it blinks per second in a second.
Sure. That's true. The problem with that is, even if you were doing blinks per second, or get the camera, you're measuring a distance it went, and you're measuring a time based on this. Where that's still a distance time measurement. I want to know how you can measure the speed directly.
Look it up.
On what?
Maybe it says on the bottom of the
The
box of the car.
I mean, you have all been in a car, right?
Yeah.
What's that thing in your car that tells you how fast you're going?
It's an
So
hour.
now it's a car.
Now, it's the speedometer. Have you ever seen it? It's a speedometer, right? Right? Look at the cluster on this. Does it have a speedometer in there? No, there's no speedometer in there, right? I think the interesting thing about this is that neither of these measure the speed either. A radar gun sends a radio wave down and it hits and it changes the frequency, and the radar gun measures the difference in frequency. It's actually a frequency measure. The speedometer is attached to the wheel and it tells you how fast the wheel is rotating. So it basically measures the distance the wheel travels. Yeah.
No, I was about to say what you said for
Oh.
the wheels.
So, is there a way to measure the speed directly?
No.
Joe goes, yeah, but no. Okay. Definitely one of those two. I like it. Yes, Sam.
You could like weigh the car and then like run it into something and then get the momentum.
I suppose that's true, right? You the destructive, but then you're still not measuring the speed. You're still trying to calculate the speed. Isis.
I don't think you can measure it directly, because isn't speed like whatever units you use, it's always going to be like derived units, no matter what.
Okay, that is a distinct possibility. You guys hear what she said? She said if you think about the way that Jackson said it, it's miles per hour, or you could do feet per second or meters per second. She says it's always going to be some sort of derived quantity. Okay? What's that? What? Okay. I think you're talking to me. So, can we measure the speed directly? I don't think so. So what can we measure directly?
Distance and time.
Can we measure distances? Sure, what are we going to use to measure distances?
Start.
Okay. Well, could you use a meter stick to measure distances?
Yeah.
Okay. You can use a meter stick to measure distances. What do you use to measure time?
Stopwatch.
Some sort of stopwatch or something? Right? Okay. You use some sort of stopwatch to measure the time? Do those seem reasonable? All right, so here's the deal. Okay? We're going to do this lab. Okay? We're going to do this lab. The problem with this, okay, the problem with doing it this way is this only gives us one data point. You set up one distance and you get one time. Okay? Right? That doesn't tell me whether the speed is constant. That just tells me like what the average speed of the car was. Does that make sense? All right, so you've been in a car, true? What are the units for the speed of a car? Check your neighbor now. What are the units for the speed of a car? What are the units for the speed of a car? Okay. What are the units for the speed of the car?
Miles per hour.
Miles per hour. Now, the thing about this is they write mph in the car. I don't love this because you have to infer something from this, right? What does the P mean? So really, this should be like miles per hour. Does that make more sense? Is that okay?
Yeah.
Is that, those seem the same to you?
Yeah.
Now, in here, miles would be a little bit too big of a measurement, and hours would be a little bit too big of a measurement, because we're not real cars. What kind of units do you think we're gonna use in here for
Meters
speed?
per minute.
Meters per second.
Yeah, meters
So
per
I think we're probably gonna use here, we can measure in meters, right? And then, does meters per second seem okay? Does that seem reasonable? So far, so good? So, on your lab guide, this is the Buggy lab. Okay, on your lab guide, this is the Buggy lab. Yeah, it's called the Buggy lab. Doesn't this look like a little dune buggy to you? Look at the cute little hippie flowers on front. Look how adorable they are.
It's missing mirrors.
It's, well, it's a dune buggy.
That's a lab saver. I mean, that, well, I don't know. I just think it should have mirrors. I agree.
It might be safer if it did. So this is the Buggy lab. Okay? Now, before you write this, we got to decide what we're going to graph. Do we have to graph some sort of distance-time relationship? Okay? Here's the hard part. We got to decide which goes where. Is it distance here and time on the bottom, or is it time here and distance on the bottom?
Can it be interchangeable like this?
We could do it either way, except for I want my units to be like meters per second.
I think time should go on the bottom.
You think time should go on the bottom?
Yeah.
Okay?
Yeah.
I mean, let's see if that makes sense. If I put time down here, measured in seconds, and I put my distance here,
Time goes on top.
Okay, time goes on.
well, I don't know, we're
Wasn't it-
checking.
No, it's rise over run now.
Okay? So Isis, say it again.
It's rise over run, so.
If I'm looking for the slope of this line, how do you calculate the slope? Rise over run, true? So what are the rise units?
Meters
Meters, what are the run units?
per second.
Second, is that gonna give me what I want?
Yeah.
If I did it the other way, if I put seconds here and meters here, the units would be seconds per meter. That doesn't make any sense, right? That is something, but we're gonna talk about that later this week. So here's what I want you to do. In the upper right-hand corner on your, there's a little axis. I want you to label it with distance and time. What do you think the research question is? What is the relationship between the distance and time for the Buggy? Absolutely. Okay? Write the research question, label your axes, draw a predictive graph. Man, I love the second one. Okay, good predictions. Make a prediction on your prediction. Good prediction. Don't forget to label those. Label, good. Prediction, don't forget to label. Good, good. Make prediction. Good, good. Good. Did you say terrible? Terrible. Are we done? Are you sure? I feel like we got 5 minutes left.
Yeah, 1 second.
Are you positive?
No, trust me, we got this down.
44, we get out.
I don't know if that's true.